Don't channel. We will be doing question number 19, chapter 11. Okay, it's not too difficult question. It has two parts. So part one says, part A says an arithmetic progression has a second term of 8 and fourth term of 14. Okay, you remember the arithmetic progression has nth term by A is the first term plus n minus 1 into D. So second term, so A2 has to be A plus 2 minus 1 into D. So A plus D, and that is equal to 8. And the fourth term, so A fourth is similarly A plus 4 minus 1, 3D, and this is equal to 18. Okay. You see, when you see the problem, it sounds, in the beginning, it may sound very difficult. You're talking about the second term is this, and the fourth term is this, and you have to find how many terms you need to sum up 1560, 1560, right? So don't be overwhelmed by this statement. Try to write the information whatever is available. So we are given these two information, these two pieces of information. You see now I have two equations and two unknowns. I will solve them. So let's try to subtract one equation from the other. So a plus 3d equals 18 and a plus d equals 8. So let's subtract these equations. So this plus will become minus, minus, and plus become minus. It cancels. 3d minus d is 2d. And 18 minus 8 is 10. So d is equal to 5. Okay. Now knowing this d, and I will use this equation again. Remember here a is equal to 8 minus d. So 8 minus 5 will give you 3. So the first term a is 3. Okay. And d is 5. These are the two important pieces of information we have learned. Okay, now the interesting thing. Find the least number of terms for which the sum of these progression is greater than 1560. Remember, sum of n terms of an arithmetic progression is n by 2, 2a plus n minus 1 into d. Okay, I hope you all know this thing. So if I want to make this sum equal to or greater than 1560, and I don't know n, so n by 2 and 2 times a. A is 3, so 2 times a becomes 6. Plus, again, I do not know n, but d is known to be 5, right? And all those things should be equal to at least or greater than 1560. Okay, find the least number of terms. Okay. So from here, you can see if I multiply 2 with this one and open this bracket, it is 6 plus 5n minus 5 equals, when I multiply 2 with 1560, it becomes 2, what did I do this calculation? 3, 3120. 3120, 3120. Okay, and 6 minus 5 is 1, so it will become n into 5n minus 1 equals 3120, and it will become 5n square minus n minus 3120 equals, okay, I'm putting equal. So let's do it for equality here. Okay. Now this is a quadratic expression. So let me solve it using quadratic formula. So n is equal to minus b plus minus under root b square minus 4 into a into c. So c is negative 3000. So I will make it 3120. And because of this negative, I make it this thing positive. Okay, no problem. And all things divided by 2a means 2 times 5. Okay, so when I solve this thing using my calculator, I got two answers. One is positive, which is 24.88, I believe, and second was negative. So negative answers anyway not unacceptable because n has to be positive. So and remember we always have a greater than sign here. So n should be equal to 25 because next in integer which is next after 24.8 is 25. Okay, so when I have 25 terms, it will add up to something great, more than 1560. Okay, now let's do question B. Okay, I don't like this color, so let me choose some other color. This one. Okay, so uh, we're doing this second part B. A geometric progression has a sum to infinity of 72. Remember, sum to infinity of an geometric progression is a over 1 minus r. So this is known as 72. We do not know a, we do not know r, but the sum of infinite terms is 72. This is one piece of information. Second piece of information is sum of the first three terms is this much. So first term is a, second term is ar, third term is ar square. Make sense or no? And this sum is known as 333 over 8. Okay, so using these two equations or these two pieces of information, we need to find the value of the common ratio A and R. So in other words, I have two equations and two unknowns, and I have to solve them for uh, both unknowns. Okay, so the second equation, if I simplify it a little bit, A common is 1 minus R, sorry, 1 plus R, and plus R square is equal to 3338 over 8. Okay, if I substitute A from here, remember this means that A is equal to 72 times 1 minus R. So I will put this value of A over here. So A can be replaced by 72 times 1 minus R into 1 plus R squared. And this is 333 over 8. I take 72 this side, so it will be 1 minus R into 1 plus R squared, and it is 333 over 8 over into 72. And I saw this after simplification, it remains 37 over 64. Okay. At first glance, this is a very difficult equation. It has become a cubic equation, right? And there's no closed form solution for a cubic equation. But let's not stop over here and try it a little bit more. Okay, so if I multiply these two brackets, it's going to be 1, okay, plus r and plus r squared. And now multiply with minus r everything. Minus r squared and minus r cube, okay, equal to 37 over 64. Okay, this minus r comes cancel with r, and r squared cancel with minus r squared. So I have only 1 minus r power 3 equal 37 over 64. So this is giving us some good hope. Okay, let me make some room for us. Eh, this should be enough. Okay. Now, yes. Okay. So I have 1 minus r power 3 equals 37 over 64. So you can see that 1 minus 37 over 64 is equal to r power 3. Okay. So r power 3 is equal to, when I simplify this thing, 1 minus 37 over 64. It gives me 1 is 37 over 64. Yeah, it gave me 27 over 64. 27 over 64. And if I take cubic root on both sides, then R is equal to 3 by 4. Okay, interesting. In the beginning, we didn't have any room. Okay, let me make some more room. Okay, so we found R. Now we need to find the first term. Remember, first term A, it was equal to 72 times 1 minus R. I'm talking about this expression here, right? Okay, so it is 72 into 1 minus R is 3 by 4. So 1 minus 3 by 4 is 1 by 4. So 72 times 1 by 4. So it is going to be 80. So the first term of this progression is 80. Okay, I hope everything is clear. If you ever have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.